Assalamualaikum. Okay, now we proceed to the calculation part of this chapter where you are required to construct a control chart or a P chart. Okay, to show you how to construct a control chart, I'm going to use example 13.4 from your textbook. So please refer to that example. Okay, the question here says, Ehsan Shoes Neighborhood, a producer of sports shoes, has been concerned about the number of defective shoes found recently. Its production manager selected 10 random samples of 100 units of each for inspection to evaluate the problem. The number of defective shoes found in each sample is as follows. Okay, what the question here says is that this company is producing shoes and the company is having defect problems with the shoes. Defect means benda yang reject lah. Okay, rejected items or rejected shoes. So the manager is conducting an inspection to see what is actually the problem. So the manager is doing a sampling inspection. Okay, inspection. Sampling inspection where the manager check or inspect only a few samples. Okay, over here it says 10 random samples of 100 units each. Okay, in order to find the defective shoes in each sample. So what you are given here in the table is the data from the 10 samples. Okay, so we have sample number 1 until sample number 10. Before we proceed with the calculation part, I just want to highlight to you the meaning of this. Okay, starting from 10 random samples of 100 units each. Okay, you need to understand the concept of sample first. Okay, 10 random samples or 10 samples here. Okay, it doesn't mean or it does not refer to 10 units of samples. 10 samples here refers to 10 groups of samples. Okay, sample number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 samples over here, okay, which refers to these 10 samples of 100 units each, meaning that every sample has 100 items of products to be checked. So in this question, it refers to shoes lah. Okay. So satu sampel ni bukan mempunyai satu unit produk yang diperiksa ataupun diinspect. One sample, there are 10 items or 10 shoes must be inspected. Second sample also has the same number of items, which 10 or 100 items or 100 shoes will be checked. So every sample here from sample number 1 until sample number 10, each and every sample here has 100 items or 100 units. Okay, as mentioned in the question. So satu sampel bukan bermakna satu unit. Satu sampel ni adalah satu group sampel in which dalam sampel tu mempunyai 100 unit. Okay. So what we can see from this record or data that has been presented over here, sample number 1, the number of defective shoes is 1, meaning that when the manager checks sample number 1, meaning that checking all the 100 units of shoes just now, 1 defective shoes is found. Satu kasut rosak dijumpai. So that is meant by 1 number of defective shoes. When the manager check the second sample, sample number 2, check all these 100 units of shoes, the manager found 0 defective shoes. Maksudnya sampel number 2 ni daripada 100 ni tak ada satu pun kasut yang rosak, defective. Sample number 3, 2 defective shoes found. So check sample number 3, how many units check? 100. And from 100 here, there are 2 shoes are defective. So that is the meaning of the numbers given here in the table. Okay. So the question here says, based on the above information, develop a P chart with Z equal to 3. Is the process under control? Explain your answer. So you are required to develop a P chart first with Z equal to 3. So later I explain to you what is meant by Z equal to 3. Okay, the first step to do is to calculate the average fraction defective. So P bar symbolizes the average fraction defective. And the formula is summation of x divided by summation of n. X here stands for defects. Barang rosak. And n here stands for samples. Okay. So summation of n, meaning that total of n or total defects, what you have to do is you just add up all the number of defects per sample in the second column from the question and you will get 23. Okay, from sample number 1 until sample number 10. How many defects are there according to sample number? You add up all and you will get 23. That is in the second column. Yeah? And for the summation of n, or we call it as total sample. Okay, kat bawah ni adalah total sample. Total sample. Total sample is where you focus on how many samples we have as given in the question. So we have 10 samples altogether, and in each sample we have 100 units. So you have to take 10 samples multiply with 100 units. That will become the summation of n, or the total sample. So 10 times 100, it is 1000. So the P bar is 0.023. So the P bar here is to be used as a center line. Okay, center line on the graph. So graph nanti, P bar will be drawn in the center or on the center. So once we have calculated the average fraction defective, step number 2 is to calculate the standard deviation. So this is the symbol for standard deviation as P bar. So the formula for standard deviation is P bar times 1 minus P bar divided by n. Okay, this is the original formula given. You can check from your textbook. P bar times 1 minus P bar divided by n. Okay, we have calculated P bar. Okay, 0.023 over here. This is your P bar. 1 minus 0.023 times 0.023 divided by n. N here is the sample size. Size sample. So sample size here, maybe you will be a bit confused between these two numbers. Is it 10 or is it 100? Okay. So 10 here is actually 10 samples, not the size of the sample. Kita ada 10 bilangan sample. And in each sample we have 100 units. So what is the sample size? So each sample the size is 100 units. So this is not the sample size. This is the one. So 100 is n, that is the sample size. So satu sample, berapa size dia? That is 100 units. So the standard deviation is 0.015. Don't forget the square root over here. Okay, next is to calculate the UCL. Okay, UCL here stands for upper control limit. That is the line, the upper line on the graph. Okay, the formula for UCL is P bar plus Z score times standard deviation. So we have calculated the P bar, that is the average fraction defective, and we have also calculated the standard deviation. Okay, a new item here in the equation is the Z score. Okay, Z here stands for confidence interval. Okay, you don't have to understand what is actually the meaning of confidence interval, but you just take it as Z represent confidence interval. Okay, there are 3 types of confidence interval, which is given here. First is Z score that is at 90, the confidence interval that is at 90%. And the confidence interval at 90% has a value of 1.64. Confidence interval of 95% has a value of 9.16. And the confidence interval at 99% has a value of 3. So these 3 are actually the Z score. Okay. Sometimes the question mentions the percentage, Z score in percentage. So you have to memorize these values. And sometimes the question directly gives you the value. So whatever value given, you have to use it. Okay, unless the question gives you the percentage. So in this question, the question directly gives you the z-score of 3. Okay, 3. Yeah? You can see from the question on the first page of that example, right below the table, based on the above information, develop a p-chart with z equal to 3. So z is 3 over here. So we just use directly what is given. So p bar or average fraction defective has been given, has been calculated, which we got 0.023. Z-score has been given in the question, that is 3. And standard deviation is 0.015. So you just put in whatever numbers that we have got earlier. And we got, it will give us an answer of 0.068. So this will be the UCL, that is the upper control limit, that is the upper line on the graph. Then next step, number 4, that is to calculate the LCL, that is lower control limit. Okay, so the opposite of UCL. So LCL is using a similar formula, but we change the symbol over here. Okay, so P bar or average fraction defective minus of the z-score times standard deviation. So 0.023 minus 3 times 0.015, and we will get negative 0.022. Okay, normally it will give us negative answer. So when we get a negative answer, we have to convert it into 0, meaning that on the graph, the lowest line should be 0, not negative value. So that's why we convert it into 0. If we get a negative value only, negative answer. But if you get a positive answer, you have to maintain that answer. Okay. So now we have done with UCL and LCL. So LCL will be the lowest line on the graph. Okay, the last thing that we must calculate before we go and construct the P chart or the control chart is fraction defective, or the symbol is P. So it is not P bar. P bar is the average fraction defective. This is not the average. Okay, so it is only P. The formula is X divided by N. So what is X? X is defects. Okay, defects. So how to get the info for defects? It comes from the question, this one. Okay, so column A and column B here, they are from the question. You are given these two columns. So X comes from here, and N here is the sample size. Okay, sample size. So sample size here, as written in the question, we have 10 samples, and in each sample there are 100 units of shoes. So 100 units, that refers to the sample size, that is N. Okay, dalam satu sampel tu ada berapa bilangan dia? That is N in this case. So what we do for fraction defective is we take X, that is over here, X. Okay, every sample has its defect, so which we call as X. We divide by the sample size, that is 100. Okay, from the question. So whatever number that we have over here, okay, sample number 1, we found 1 defect. Sample number 2, 0 defect. Sample number 3, 2 defects. We just divide by 100, that is the sample size. Okay, standardized sample size. So we get all this as the fraction defective. So what is the purpose of calculating the fraction defective? This is used to plot the graph. Kita akan gunakan data ni untuk plot the graph later on. Okay, so it is very easy. Column 1 and column 2, you just take from the question and you come up with column number 3. Just take the numbers given in the second column divided by the sample size. Okay, and now we go to constructing the P chart or the control chart. Okay, so we have performed the calculation earlier. Okay, we have calculated the 3 lines that should be drawn on the graph. The first one, we call it as the P bar. Okay, the first calculation that we did just now, it was P bar, the average fraction defective, and we got the answer of 0.023. And P bar must be drawn as a center line. Okay, so we have, okay, what we have on the graph is, on the x-axis over here, this is the sample. So in this question, we have 10 samples from number 1 until number 10. So kita letakkan sahaja bilangan sampel di sini. And what we have on the y-axis over here are the values that we have calculated. Okay, proportion of defectives. Okay, so whatever values that we get, we have to draw the lines first. We have to draw the 3 lines first. First is the P bar, center line 0.023. So let's say 0.023 is about here. So we draw a straight line. It should be a straight line. So this is the P bar, a line with a label. Second is the UCL, upper control limit. As I mentioned earlier, UCL is the upper line on the graph. The value for UCL that we have calculated earlier, it was 0.68. So 0.68, it is about here. So we draw a straight line. So this one is the UCL. Okay, and finally the LCL. LCL, the value that we calculated just now, we got negative answer, and we have to convert it into 0, meaning that on the graph, the lowest value should be 0, not negative numbers. So 0 is over here, so this is actually the LCL. So we have drawn the 3 lines, 1, 2, and 3. Okay, and next one, what to do is to plot the graph by using the fraction defective. That is the one that we calculate, the last calculation that we did just now. Okay, so we go sample by sample. Okay, sample number 1, the fraction defective is 0.01. So it is about here, di sini. Okay, sample number 2 is the fraction defective is 0. So it is over here. Sample 3, 0.02. It is up here. Okay, roughly. Sample 4, 0.03. Up here. Sample 5, 0.04. Up here. Sample 6, 0.02. Over here. Sample 7, 0.04. Over here. Sample 8, 0.01. Over here. Sample 9, 0.02. Sini. And lastly, sample 10, 0.04. Over here. Okay. And now, what should be done next is to connect all the points. Okay? Connect all the plots from sample number 1 until sample number 10. So number 1 going to number 2, going to number 3, should be straight, going to number 4, 5, 6, 7, 8, 9, and 10. So this is the control chart. Okay, so your control chart now is done. Very easy. Next is to come up with a conclusion, meaning that we have to make a decision on the sample. Okay, so the conclusion here is based on the control chart that we have over here. It is related to what to accept, okay, which samples to accept, and which samples to reject. So kita nak accept sample mana, kita nak accept reject sample mana, accept or reject which sample. So we have to mention. So how to make a decision over here? What we have to focus on the graph is just this range. Range yang boleh diterima, quality yang boleh diterima adalah from UCL going down to LCL. So sample yang berada dalam range ni, from LCL going to UCL, so these samples are within acceptable quality range. So these samples can be accepted. The samples that fall outside the range, katalah tiba-tiba ada sampel number 7 ni, when we calculate the fraction defective, it is 0.07 kat sini. Kita plot dia 0.07. So it is outside or it is beyond this UCL line. So this sample later on must be rejected because it is out of the acceptable quality range. Maksudnya range ni, quality level sample tu masih boleh diterima oleh organisation. Okay, so now in this case, we look at this P chart or control chart from sample number 1 until sample number 10. All samples are within the acceptable quality range, that is from LCL going to the UCL. So the decision that we have to make is all samples are accepted. Okay, meaning that semua sampel ni kita terima because they are within quantity range. Okay, so the textbook here says the process is under control. All samples fall within the control limit. So in other words, all samples are accepted. Okay, so if let's say, as I said earlier, sample number 7 is out of the range, katalah tiba-tiba ada sample number 7 tu terkeluar daripada range dia. So what we do is, how to write the conclusion is, you just come up with this. Let's say sample 7 is rejected and other samples are accepted. Meaning that you don't have to list the sample number because you can shorten it in this way. Okay, so that is how we construct a control chart and come up with a conclusion or decision related to the samples. So with that, that's all for this chapter. And thank you.